Have you ever sent a WhatsApp message and wondered what actually happens after you tap send? Or maybe you have uploaded a YouTube video, sent an email, or joined a video call. It feels instant, but behind the scene, your data goes on an incredible journey. Your message travels through wireless signals, routers, switches, internet service providers, and servers, and sometime across entire continents in just a few seconds. So, how does every device involved know exactly what to do? How does your message leave your phone and arrive correctly on someone else's device? The answer lies in one of the most important concepts in networking, the OSI model. Today, we are going to break down all the seven layers of the OSI model in a simple, visual, and beginner-friendly way. And by the end of this video, you'll finally understand how data moves through a network. So the OSI model stands for Open System Interconnection Model. It was created by International Organization of Standardization or ISO. The goal was very simple. Create a standard framework that explains how computers communicate over networks. Think of it as a blueprint for communication. So instead of trying to understand networking as a one giant complicated process, the OSI model divides everything into seven smaller layers. Each layer has a specific job, and together these layers allow devices around the world to communicate successfully. We'll use one example throughout this entire video, sending a WhatsApp message from your phone to your friend's phone. Watch how that message travels through all seven layers. Before diving deeper, here's the complete stack from top to bottom. At top comes the application layer, then presentation, session, transport, network, data link, and physical layer. So let's start from the topmost layer, which is the application layer. This layer is the closest to the user. This is where applications like WhatsApp, Gmail, YouTube, and web browser interact with the network. Think of this layer as a receptionist in an office. You tell the receptionist what you need and they start the process. When you type a WhatsApp message and press send, the application layer receives your request. It doesn't actually sense the data itself. Instead, it provides network services to the application. In our example, the message begins its journey here. Next comes the presentation layer. This layer acts like a translator. Imagine two people speaking different languages. A translator helps them understand each other. Similarly, computers often store and represent data differently. The presentation layer converts data into a common format. Not only this, it also handles encryption and compression. For example, WhatsApp encrypts messages so that only sender and receiver can read them. So our messages like, hey, are you free today? Gets encrypted and prepared for transmission. Now it's secure and ready for the next layer. The session layer manages conversation between devices. Think of it like a starting and ending a phone call. Before two people can talk, a connection must exist. The session layer establishes, manages, and closes communication sessions. When your phone starts communicating with WhatsApp server, this layer helps maintain that connection. If communication is interrupted, the session layer helps recover or restart the conversation. Now our messages has a communication channel ready to use. Now comes the transport layer, which is responsible for reliable delivery. Imagine sending a large book through the mail. Instead of one huge package, you split it into smaller boxes. That's exactly what happens here. The message is divided into smaller pieces called segments. Each segment receives sequence information. This allows the receiving device to reassemble everything in the correct order. Common protocols here include TCP and UDP. UDP focuses on speed and TCP focuses on reliability. Application like messaging often depends on reliable delivery. So our WhatsApp message gets divided into segment and prepare for transport. Now we arrive at the network layer. This layer is responsible for finding the best path to the destination. Think of it like GPS navigation. If you're driving somewhere, your GPS chooses a route. The network layer does the same thing for data. It uses IP addresses. Every device connected to a network has an address. Routers operate here. They examine packet destination and decide where to send them next. Our WhatsApp messages now knows exactly where it needs to go. Our next layer is data link layer, which handle communication within the local network. Imagine you are inside a large apartment building and you already know the building address. Now you need the correct apartment number. That's what the data link layer helps with. It uses MAC addresses to identify devices on the local network. At this layer, data is packaged into units called frame. Switches operate here and help move frames to the correct device. Our message is now ready for physical transmission. Finally, we reach the physical layer. This is where data becomes actual signals. Electrical pulses, light signals, radio waves, everything here is about transmitting raw bits, ones and zero. Network cables, fiber optics, Wi Fi, antennas, and connectors all belong to this layer. Our message is now physically traveling through the network, from your phone across the internet towards your friend's device. As data moves down the OSI model, each layer adds its own information. This process is called encapsulation. Imagine shipping a gift. First comes the gift, then a box, then a shipping label, then tracking information. Each layer wraps the data with additional instructions. By the time it reaches the physical layer, it is fully prepared for transmission. When the message reaches the destination device, the reverse process happens. This is called decapsulation. Each layer removes the information added by the corresponding layer on the sender's side. Eventually, the original WhatsApp message is reconstructed, and your friend sees, "Hey, are you free today?" almost instantly. And if you need an easy way to remember all these 7 layers, use this famous mnemonic. Please do not throw sausage pizza away. Please represent presentation. Do for detailing, not for network, throw for transport, sausage for session, pizza for physical, and away for application layer. Or remember it in reverse order depending on your preference. It's a So in real-world networking, you'll also hear about TCP/IP model. OSI has 7 layers. TCP/IP combines some of them and uses 4 layers. OSI is primarily used as a learning and troubleshooting framework. TCP/IP is the practical model used by modern internet. Even though engineers work heavily with TCP/IP, the OSI model remains one of the best way to understand how networking works. Now let's quickly recap what we have understood in this video. Application layer provides network services to applications. Presentation layer translates, encrypts, and compresses data. Session layer manages connection. Transport layer ensures reliable delivery. Network layer handles routing and IP addresses. Data link layer manages local communication and MAC addresses. Physical layer transmits bits through cable and wireless signals. Understanding these layers makes troubleshooting much easier. If a website isn't loading, is it a cable problem, a router problem, a transport issue? The OSI model helps network engineers isolate and solve problems efficiently. And that's exactly why it's still taught in networking courses. If this video helped you understand networking better, don't forget to like, subscribe, and share. And let me know in the comments which networking topic you'd like to learn next. Thanks for watching, and I'll see you in the next video.